Second lesson on lines. Last time I promised you the staircase today, and a trick that rewrites its own instructions somewhere down the road. I have to break that promise in the good direction. The slanted line wants the trick immediately. So today you get both. First, the fact everything else stands on. An instruction is bytes. Not like bytes, it is bytes, and they live in the same memory as your data, with nothing standing guard between them. A program can read its own code, and it can write it. Today, that idea has a name and a marketing department, just-in-time compilation, JET. A program writing, at runtime, the exact instructions the moment needs. In 1986, it was called self-modifying code, and it was simply how a line drawer earned its speed. The numbers first the same two screens as Lesson 7, B800 for text, 1000 for pixels, and the toy screen is back for one frame, so its 5x4 is here too. The words of the lesson as data. 2 frames of this lesson are almost all words. One of them is a warning you will want on the wall. The state. Most of it belongs to the line drawer we will write near the end. The two ends of a line. the two distances, the two steps in the pair the loop itself owns, the long distance and the short one. Ignore them until frame 5. They are just parked here. Now the two stars of the middle of the show, two routines that draw the same diagonal, and the difference between them is the whole lesson. And that little jump to the very next line, it looks like it does nothing. It is the most important. The toy screen, cell, and grid. Back from lesson 7, the debt walk in frame 4 wants them. Then the hint line, a headline, and the boot. The first frame, watch the middle of it. SI is pointed at the address of the add inside slope JIT and LODSB reads it like any other data. Because it is data, 4 bytes, printed in hex, straight off the live program. And away out the last 4 lines of the file. As always, save, leave, assemble. Nothing fetched that, but LODSB. The processor did not mind. The memory did not mind. Code enjoys no protection of any kind on this machine, which means the door swings the other way too. What can be read can be written. Now we use the door. 2 crosses drawn by the 2 routines you just typed. The yellow cross asked a question at every pixel up or down 480 times, and the answer never changed once. The green cross asked it twice, wrote the answers in identical pictures. That is the point. The machine did the same work, it just stopped asking about it. On a processor where a take and jump costs 16 cycles, that is not style. That is speed you can feel. Before this gets comfortable, the warning, this trick has a tooth, and the tooth is invisible in exactly the place you would go looking for it. While one instruction runs, the 8086 has already read the next 6 bytes of code into its prefetch queue. Real silicon, a real copy. Write over a byte the queue is swallowed, and your write lands in memory but the OLD byte executes. Any jump empties the queue. So the rule is 3 words long. Patch, then jump. That is what the little jump in slope JIT buys 2 bytes of insurance. And here is the cruel part. A debugger walks code on interrupts, and an interrupt empties the queue too. So under the debugger, the stale byte is flushed at every step and the bug does not exist. Let the program run free, and it bites. The one bug your debugger is built to never show you, which is why this is a rule, and not a memory. Now the slanted line itself. No trigonometry, no fractions of staircase, counted with nothing but adding. Watch the det. Every 4 across, 2 down, and the downs land as evenly as whole steps can land. That is the staircase you have seen on every slanted line ever drawn on a pixel screen, and it came out of 2 adds in a compare. In the books, this walk is Bresnan's algorithm, worked out in 1962 for a pen plotter. The machine does not know the name. It knows the det. Now everything at once. The det makes the slope, the rewritten add make the direction. One routine, every direction on the screen, and this block goes up TOP with the routines, under jump boot, because a routine is what it is. And what is left inside the loop is frame 4, word for word. A write, the debt grows, the debt pays, 2 adds. The 2 adds are save, out, and back in for the frame, because a landing per session is how this file stays on us. "67 lines, every direction there is, one routine. Steep ones, shallow ones, backwards ones the fan does not care. The det handles the slope, and the code the program wrote into itself handles the direction. So now you own the whole kit, across and down from lesson 7, the slant from today, and the 86 trick the modern books call JIT with its one iron rule. Patch, then jump, and never trust a debugger to tell you broke it. Next time the 3 lessons meet, lines that share their corners, a ship, a wireframe, the first skeleton of a world.